Okay, so we're going to review for the quiz that I'm going to be posting tomorrow. So this is just a review of what we were doing on area and perimeter and circumference, okay? All right, so for question number 1, and I'm going to also be posting the answer key to the review, so you can also look at that. The circumference of a circle with a radius of 8 centimeters is 8 pi centimeters. So true or false? Okay. So we know that the formula for the circumference of a circle, is pi times diameter. Okay. So if we have a circle with a radius of 8, that means that my diameter is 16 because the radius is half of the diameter. So then if we plug this in for the d in the circumference, we get that the circumference is equal to pi times 16, which is also 16 pi. So this statement is false. Okay? All right. Number 2. If the area of a square is 64 centimeters squared, then its perimeter is 32 centimeters. So we know that to get the area of a square, what we're doing is length times width. Now the other thing we know about a square is that all the sides are congruent. So if I'm multiplying the length and the width, and we know that they're going to be equal to each other, we could just say length squared, because they're equal, is equal to 64. Okay? And then taking the square root of both sides gives us that the length, which is also the same as the width, is equal to 8. So what that tells me then is that each side is 8 centimeters. And then when you add these up, we get 32. So the perimeter is equal to 32. So this is true. Okay. And then on number 3, the area of a circle with a radius of 7 centimeters is 49 centimeters squared. I think this is a typo right here. I'm pretty sure I meant to type in 49 pi. Because without the pi, we know it's definitely not going to be correct. So, area of a circle is pi r squared. And so we're going to plug in our radius of 7. So that is, oops, jumping to the wrong page. Hang on one second. So, just erase my, okay. So we're doing pi times 7 squared, which is pi times 49, which is equal to 49 pi. Okay, so this statement then is true. Okay? All right, so moving on from there. Okay, looking at number 4, which formula would you use to solve for the area of the shaded region in the given diagram? So when we're given problems like this and we want to solve for the shaded region, the first thing you want to do is get the area of the entire thing, in this case being the rectangle, and you want to subtract off the parts that you don't want. So we don't want the 2 circles, so we're going to subtract the area of that off, okay? So the formula for area of a rectangle is length times width, okay? Now the formula for area of a circle is pi r squared. So in this particular example, we'd be doing whatever the length times the width is, minus, now since we have 2 circles here that are of equal size, we'd be subtracting 2 times pi r squared, okay? So looking at our answer choices, that is choice 3, or choice C, okay? All right, and last one on the page, number 5, find the area of the triangle shown. So our formula for area of a triangle is 1/2 base times height. So now in this problem, we have the base, we don't have the height though. So we do have the hypotenuse, and we know that this is a right triangle, so we can use the Pythagorean theorem to help us solve for the height. Okay, so this would be my A, B, and C. Okay, so A squared plus 9 squared equals 41 squared. So now we've got this. Subtract the 81 over. And then we end up with, I'm going to keep, writing over here. Now we end up with A squared is equal to 1600, square root both sides, and A is equal to 40, okay? So now we know that the height of our triangle is 40, okay? So now I'm going to take my base and my height and just plug them into this formula. So I'm going to actually just move this over a little bit. Okay, so we are doing 1/2 9 times 40, which is 180. So 180 centimeters squared. Now, I don't know if I mentioned this before, but I will also be posting a copy of the formula sheet, so you don't actually need to memorize any of these formulas. If you did, that's great, but you don't actually have to. You will have that available to you on any test, so you don't need to worry about that. Okay? All right, let's look at number 6. So calculate the following triangular area with the following vertices. Okay, so this is one of the problems where, because we can't count the boxes to actually see what the base and the height are of this triangle. So in order to do this, what we're going to start off by doing is drawing a rectangle around our triangle. Okay, and what we're going to do is we're going to find the area of the entire rectangle and then subtract off the pieces that we don't want, which are the 3 triangles. And I just labeled them triangle 1, 2, and 3. Okay, so I'm going to move back over here. So we'll start off with the area of the rectangle. So we're just going to count the boxes for the length and the width. So it looks like we've got 7 by 5. Okay, so 7 times 5 gives us 35, okay? All right, now I'm going to get the area of each one of my triangles. So area of triangle 1, triangle 2, and triangle 3. Okay, so we know that these are all going to be 1/2 base times height. We just have to count and see. Okay, all right, so let's look at triangle 1. So triangle 1 has a base of 2 and a height of 4. So 1/2 of 2 times 4 is just 4. Okay. Now triangle 2 has a base of 1 and a height of 7. And if you multiply that, you'll get 3.5. And then for triangle 3, we have a base of 5 and a height of 5. Oops, hang on. Okay, so when we multiply that, we get 12.5. Okay, all right, so now, once we've done that, we're going to add up these 3 numbers, because those are the 3 pieces that we don't want. Okay, we're subtracting that off because we just want to get the area of the original triangle that we had in the diagram. So when we add that up, we get 20, okay? And then our final step is just to subtract. So 35 minus 20 gives us 15 units squared. Okay? All right, so anytime you get a problem like that, it's really always the same procedure. Draw your rectangle and then subtract off the pieces that you don't want. Okay? All right. Moving on to number 7. So number 7 is a population density question. So this is the formula in this unit that you actually don't get. So you have to remember that the formula for population density is equal to population divided by area. Okay, so in number 7, during an experiment, the same type of bacteria is grown in 2 circular petri dishes. Petri dish A has a diameter of 21 centimeters and approximately 120,000 bacteria after 1 hour. Petri dish B has a diameter of 26 centimeters and has approximately 140,000 bacteria after 1 hour. Determine and state which petri dish has the greater population density of bacteria at the end of the first hour. So for this problem, we're going to have to figure out the population density for both petri dish A and B. Okay, let me just erase this so I have more room. All right, so give myself a little bit more space. Okay, so let's start off with petri dish A. Okay, so petri A. All right, so if I want to get the population density, I'm doing the population divided by the area. So we know that the population of petri dish A is 120,000. Now, we don't actually know the area right now. We need to figure that out, but we have enough information that we can do that. So for the area, I'm just going to kind of do that a little separate over here. If it's a circle, we know our formula is pi r squared. And we were given that the diameter of petri dish A is 21. So what that tells me is that if I divide that by 2, my radius is 10.5. So this is going to be pi times 10.5 squared. And I just would want you right now to type in the 10.5 squared in your calculator. You would get 110.25 and then just tack on the pi. Okay? So the area of petri dish A, this guy over here, is 110.25 pi. So that's going to be in the denominator here. Okay, so now when we actually want to put this in the calculator, it's very important that you remember to put parentheses around the denominator. If you have pi with an expression, the calculator is not going to read it correctly unless you put parentheses around it. So when you type this in, you should get approximately 346.5 bacteria per centimeter squared. Okay, so that was for petri dish A. All right, so now we need to go ahead and get our population density of petri dish B. Okay, so now this is B. All right, so we're doing the population over area. So our population is 140,000. And again, for our area, we're going to have to figure that out. So the diameter of petri dish B is 26, which means that the radius is 13. So pi times 13 squared is 169 pi, which is going to go into our denominator here. And when you type that in your calculator, you'll get 263.7 bacteria per centimeters squared. Okay, so the petri dish that had a greater population density would be petri dish A. So I would just write your answer over here, petri dish A. Okay, because clearly there is more bacteria per square centimeter than petri dish B. So this is more dense, okay? All right. Very nice. Okay, So now moving on to number 8. So number 8, what is the perimeter of the rectangle shown to the nearest tenth? Okay, so if we're trying to find the perimeter of something, what that means is that we are adding up all of the sides. So our only problem here is that we actually don't know any of the sides. What we do know, though, is that our diagonal is 10 centimeters and that we have an angle here of 30 degrees. So keep in mind that rectangles have all right angles, okay? So what you really have here right now are 2 right triangles, okay? So this is the tricky part of this problem, is that we're actually going to have to use trig before we can actually add any sides up. So I'm going to just focus right now on one triangle. I'm just going to pick this guy on the bottom, okay? And we're going to use SOHCAHTOA to help us find the 2 missing sides. Now, once we find those, we're good because the opposite sides of a rectangle are congruent. So I'm going to label this as X and I'll label this guy as Y, okay? So now let's label our opposite, adjacent, and hypotenuse. Okay, so in reference to the 30-degree angle, the X is my opposite side, the Y is my adjacent, and the 10 is my hypotenuse, okay? So let's first focus on finding X. So if I want to find X, I'm looking for the O, and we already have the H. So I'm looking over here of which trig function uses O and H. So that's going to be sine, okay? So we are going to set this up as sine. Remember, the degree measure always goes with the trig function, so sine of 30 equals X over the hypotenuse, which is 10. Okay, I'm going to put that over 1. And now what we're able to do is cross multiply. Okay, and when we do that, we get X, 1X, equals 10 sine 30, which when you type into your calculator, you should get 5. Okay, so X is equal to 5. So that means now that we know that over here, this side is 5, which then also tells me that this side is 5. Okay? All right, so now we're going to do the exact same process, except now we're going to solve for Y, which is the adjacent side. Let's get a different color. Okay, so looking at our 3 trig functions, we want to figure out who is using A and H. And if we look carefully, we see that that is cosine. So we're setting this up exactly as we set up the previous part with the sine of 30. So now we're doing cosine of 30 is equal to my adjacent, which in this case we labeled as Y, over my hypotenuse, which is 10. And again, we're putting that over 1. And we are cross multiplying. And we get Y is equal to 10 cosine 30. And when you type that in your calculator, you will get, now this question said nearest tenth, so we're just going to round our answer to 8.7. Okay? So then coming back to our original problem, just going to erase the Y. That means that this guy here is 8.7, and this guy here is 8.7. All right, so now we have all the information we need. We are able to now figure out the perimeter. So we are just going to add up all 4 sides. So 5 plus 5 plus 8.7 plus 8.7, which gives us 27.4 centimeters. Now, when you're working with perimeter, it's just centimeters. Area would be centimeters squared. And then eventually when we get to volume later this week, that's when it'll be centimeter, whatever unit you have cubed. Okay? All right. Okay, you're doing great. All right. Let's take a look at number 9 on the next page. So, given the circumference of a circle is 16 centimeters, then the diameter is, okay, so we know that the formula for circumference is equal to pi times diameter. Now in this question, they've given us the circumference, so they're telling us, okay, the circumference is 16. Now you tell me the diameter. So in order to get the diameter by itself on the right side, we need to get rid of the pi. And the way we're going to do that is we're going to divide both sides by pi. Okay, and now d is all by itself. So the diameter is equal to 16 divided by pi, which, if you look carefully, is answer choice 3. Okay? Not too bad. All right, I'm going to actually, for number 10, I'm going to teach you a little, well, I'm just going to tell you the trick for this question. A gardener has 80 feet of fence to enclose a rectangular garden. Which dimensions will result in the biggest area for the garden? Okay, any question of this type where they want the biggest area, what the dimensions would be, it's always going to be when the length and the width are equal. That will always result in having the biggest area. If the question had said smallest area, then you would pick the one where the two numbers are further apart, meaning in choice D, the length is 6 more than the width, so choice D would have the smallest area. And I think I went over this question on a previous worksheet, something just like this. So if you want to refer to that as far as the work that goes along with it, that's fine. But in a question like this, the biggest area will always be when the length and the width are equal. Okay? All right, so moving on to number 11. In the following model of an ice hockey rink, 2 semicircles are placed at the end of the rectangle shown. Which expression represents the area of this ice hockey rink? Okay, so in order to figure out this area, we need to first figure out the area of the rectangle, what I'm shading in pink. And then after that, we need to figure out the area of these 2 semicircles. Okay, so let's first figure out the area of our rectangle. So the area of our rectangle is equal to 6 times 10, which is equal to 60. Okay, all right, now keep in mind that, so that's this first part right here. So you have this whole portion. Now we need to deal with the 2 semicircles. Now keep in mind, if you have now a semicircle is half of a circle. So if you have 2 half circles and you put them together, you end up with 1 whole circle. So we need to just do the area of 1 circle, okay? Because together it becomes 1. So we're doing pi r squared. Now if you notice over here, the side of this rectangle is 6 centimeters. So that is the same thing as the diameter of that full circle, okay? Which means that our radius would be 3. So we're doing pi times 3 squared, which is equal to 9 pi, okay? Now to get the total area, then you're just taking these 2 guys and adding them together. So 60 plus 9 pi, which is answer choice B. Okay? All right. Very good. All right. A few more and then we're all done. Okay, number 12. A designer needs to create perfectly circular necklaces. The necklaces each need to have a radius of 4 centimeters. What is the largest number of necklaces that can be made from 2,000 centimeters of wire? Sorry, I needed a drink break. All right. Now, I think the trickiest part of this problem is just sort of realizing what formula am I using for this problem? So if we think about making necklaces, okay, so you need the wire to make the necklace, and we want every single necklace to have a radius of 4 centimeters, okay? So what is the largest number of necklaces that can be made from 2,000 centimeters of wire? So that 2,000 centimeters of wire is being used to make this portion of the circle that I just drew, which is the same thing as the circumference, okay? That's like the perimeter of a circle is the circumference. So in this case, if my radius is 4, that means that my diameter is 8. So the circumference of one of these necklaces, so pi times diameter, which is 8 pi. Okay? Now, that's what the circumference would be of one necklace. So I know that I have 2,000 centimeters of wire available to me, and I want to know, okay, well, how many necklaces can I make out of that 2,000 centimeters of wire? So what we're going to do is take the 2,000 and divide it by 8 pi. Now keep in mind you have the pi, so you need to put that in parentheses. And when you type that in your calculator, you will get 79.577 blah, 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 blah. Okay. Now I know that the your instinct when you see 0.5 is that you want to round up to 80. But you don't actually have enough wire for 80 necklaces. You only have enough wire for 79 and then like half a necklace. So I can't round up to 80 because I don't have that much wire available to me. So the answer here is just 79 necklaces. So that's a little tricky with kind of realizing that with the rounding, okay? That it's not following our regular notion of rounding because we're talking about a particular object. I can't round up on an object. Okay? All right. Number 13, I have the answer written out in the answer key if you would like to look at it. I'm going to omit this question, though. I'm not holding you responsible for this question on a quiz. It's really just like a testing the answer choices, but if you're really interested, you can look at the answer choice and see what I did for that one. But I would like to get to number 14, which I think is more important. Okay, so, all right, what is the approximate area of the composite figure? Okay, so we have this little figure over here. These markings tell us that we have congruent sides, and our figure is made up of 3 pieces, our composite figure. We have a square, we have a semicircle or a half circle, and we have a triangle. So we need to figure out the area of each one of these pieces and then add them together, okay? Now, if we're told that this is 8 feet, that means that all these other pieces here are also 8 feet, okay? So let's start off with the area of the square. That's pretty easy. You're just doing the length times width, so you're doing 8 times 8, which is equal to 64. Okay, so we're just going to put that aside for a second. We'll use that later. Okay, now let's go up to the semicircle. So the area for, now remember, a semicircle is half of a circle. Okay, so we're doing half of the area of a circle. So I'm just taking the pi r squared and just throwing a 1/2 in front of it. Okay, now if this whole side here is 8, that means that my radius is 4, because this would represent, if I had the whole thing, this would be the diameter. So we're doing 1/2 pi 4 squared, which is 1/2 pi times 16. And then half of 16 is 8. So we're going to leave this as 8 pi. Okay, so that is for the semicircle. Okay, now we're going to move on to the last piece, which is the triangle. Now, our formula for area of a triangle is 1/2 base times height. Now, we have a little problem here because we have the base. We know the base is 8. We don't actually have the height right now, or the altitude. We don't have that. We need to figure that out, and then from there, we'll be able to use that in our area formula. Now, keep in mind that if all 3 of these sides are congruent, that means we're dealing with an equilateral triangle. So the other thing that we know about an equilateral triangle is that when we draw the altitude going down, an altitude meaning that it's perpendicular to the side opposite, it's also bisecting that side. So that means that this side is 4 and this side is 4. So I'm going to actually redraw one of these halves of the triangle over here just so you can see it a little bit better. So what I'm dealing with right now is a right triangle whose hypotenuse is 8 and one leg is 4. So we can use the Pythagorean theorem to help us figure out what the third side is, which is actually going to be our height. So I'm just going to save you the time and let you know that our height is going to end up being the square root of 48. Okay? It'll all get rounded when you type it in at the end. Okay? So now that we have this information from the Pythagorean theorem, let's plug it into our area formula. I'll do that up here because we have some space. So the area of a triangle is 1/2. Our base is 8. Because remember, we're back to now talking about the entire triangle here. And our height is radical 48. And 1/2, hold on one second, 1/2 times 8 times radical 48. Oops. Okay, so I'm just going to do 1/2 of 8, which is 4. So I'm going to write this as 4 radical 48. Okay? All right, so now we're ready to finish the problem. And to finish it, we're just taking the 3 answers that we got and adding them together. So you're going to go into your calculator and you're going to type in 64. Oh, oops, I want a different color. 64 plus 8 pi plus 4 radical 48. And when you type that in, you are going to get 116.84555541. Now, looking at your answer choices, this is asking for the approximate area, so our closest answer to 116 would be the 120. Okay? All right, good. That was a lot going on in that problem. Now, on the next page on number 15, I'm not going to go through these composite area. You're just kind of, breaking them down and doing each area sort of on its own and adding them together. Number 16 is kind of a challenge problem, so I'm not going to be putting something that difficult on the quiz, but you can look at what I did on the answer key to see if you want to give that a shot on your own and kind of see how I did that. But other than that, that is it. Okay, this should get you ready for the quiz. But if you have any questions, feel free to send me a reminder, send me an email, and we can do a Zoom session or a Google Meet or whatever. Okay? All right. Thank you, guys.